Okay, actually, first let's do the second part, which is what should the area be? So that's the area of the circle, pi r squared, minus a half the base times the height. Now, the height is here. That's minus 3/5. So 1 plus 3/5. So that's 8/5. And then we need to calculate this. Yeah, 8/5. So, okay, we'll have to figure out this base here. Let's see where this line intersects either of these. We'll go with the one on the right. 1 minus 2x equals minus 3/5. So x equals 4/5. So the area is pi minus 16 over 25. Let's check the answer. Pi minus 32 over 25. Oh. That's only the point. I should multiply by 2. Because I've only calculated that. 32 over 25. Focus, Stephen, focus. Okay. Right. Now let's get it with integration. Is that an equilateral triangle? It's definitely it's definitely symmetric. So should be this area here. Okay, let's think about this. Okay, let's get this. Okay, so that would be 0 to 1 root 1 minus x squared dx. Sorry, minus 1 minus 2x dx plus, and then this one here, minus 3/5 minus root 1 minus x squared dx. So we've seen this integration already. It was in the previous question 56. And that's, oh, well, it's a good thing I got this point here. So that's 0 to, what did we get? That was 4/5, wasn't it? Yeah, 4/5. So we've seen this integration before already. We draw the triangle. That's x. That's root 1 minus x squared, and that's 1. So that's the integration from 0 to 1. This becomes cos u times dx, and you can calculate it. It'll be another cos u du. It's just like question 56. So it's going to be cos squared again, u du, minus integration from 0 to 1, 1 minus 2x dx, minus the integration from 0 to 4/5, 3/5 dx, plus, well, actually, minus, so minus the integration from 0 to 4/5, cos squared u du. Now remember, cos 2u is cos squared minus sine squared. So cos 2u is 2 cos squared minus 1. So it's cos 2u plus 1 over 2 is cos squared. So that will be, oh, we should multiply the answer by 2. So maybe I'll put 2 in now. So that will cancel the 2 here. So it'll be cos 2u plus 1 du minus the integration. Well, I'll put it as a plus, minus 2 plus 4x dx minus the integration of 6/5 dx minus integration cos 2u plus 1 du. Cos becomes sine 2u over 2 plus u plus minus 2x plus 2x squared minus 6/5 x minus sine 2u over 2 plus u. Whew. That would be sine u cos u, x root 1 minus x squared, sine inverse x, plus 2x squared minus 2x, plus minus 6/5 x, plus minus x root 1 minus x squared minus sine inverse x. Ooh, 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 ooh. Oh, actually, is it 0 to 1? Yeah, to here. Yeah. 0, 1. 0, 1. 0, 4/5. 0, 4/5. Yeah. Put in 1. That's pi over 2. Put in 1. That's 0. Interesting. Plus 0 minus 6/5 4/5 minus 4/5 root 1 minus 4/5 squares. That's 1 minus 16 over 25. That's 9 over 25. This isn't quite working out nicely for me. Minus sine inverse 4/5. You know, actually, when I think about it, because the curve in here, the limits actually aren't quite right. So think what I should do is calculate it just to here. No. To here, the 4/5. And then, let's think about the limit. So this one's okay. So I'm happy with this. So if we just change that to 4/5, that actually might pick things up. But then we'll have this extra piece here still. Ooh. So the good news is now if I put the 4/5 in, that will cancel with that. And that will cancel with that. So I'll just, this number here, 4/5. This one here is the 4/5. The zeros don't matter. The zeros don't matter. Yeah, okay. So let's see. Okay, that is good. That is minus 32 over 25. But now I have to add in that white piece here that I missed. So that will equal minus 32 over 25 plus twice. And we'll just calculate the upper one, which will be 4/5 1 root 1 minus x squared dx. Now, we've done this one twice, literally. So it's exact same substitution. I'll just use the formula and put in the two values. But I don't know. Will this work out to be pi? Let's see. Oh, but I forgot actually. I multiplied by 2. So actually what I have so far is this. So actually this one should be multiplied by 4. Hmm. 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 That's not quite pi. Hmm. That's a bit of a bummer. Is it actually pi at the back? Pi minus 32 over 25. It is, yeah. Hmm. Hmm. Oh, let me just add in. Let me just add in the extra integration here in red. So it was plus 4 of them. Integration from 4/5 to 1. Root 1 minus x squared dx plus 4 integration 4/5 to 1 root 1 minus x squared dx. plus 4 integration root 1 minus x squared dx. 4/5 1 plus 4 integration and the 4 integration and the 4 integration. But it's nice that I got the 32/25, but this one's not working out to be pi, which I'm not surprised. So let me just check. 0 to 4/5, which is here, and then the curve minus the line. So that should give you all of that. And then I multiplied by 2 to get that piece. Okay, so that's fine. And then plus the line. Minus 3/5. Oh, sign mistake, because this curve is minus root 1 minus x squared, and when you minus it, it becomes a plus. Right, okay. So that root 1 has a plus in it. So that's going to change things quite a bit. That one has a plus in it. That has a plus in it. So that's gone. That's a plus. So, okay. Okay. So that means we're not going to get the 4/5 canceling. So, okay. Let's see. (12/25) plus sine inverse 4/5. That's a 0 and a 0 plus minus 8/25, 0, and then 24/25 plus 4/5 12/25 plus sine inverse 4/5, and then the 0 and the 0, and then the 4 times integration. That's about a decimal, 0.327. That's 2.18 plus 12/25 plus 12/25 minus 24/25. 2.18. 12/25 minus 8/25 minus 24/25 plus 12/25 plus 0.327 plus twice sine inverse 0.8. That's 1.86. Okay, that's correct, but again, just like in question 56, by using integration, I got the answer as a decimal, and it would require so much effort not to get it as a decimal, whereas just using the regular formulas, you wouldn't. I can actually write in this integration here. That would be plus 2 times no, I'll just, yeah, plus 4 times the integration, and then it's the same thing except you're multiplying by 4 instead of 2. So it's this same thing here, but just with a 2 in it. 2x root 1 minus x squared plus sine inverse x. Um, 4/5 to 1. Oh, that's such a horrible way to do it by calculus. Oh, really terrible. Really terrible. 21 minutes? Ugh. Well, at least we got the answer in the end, huh?